Okay, good morning students. We are going to derive the formula of time period for the simple pendulum. For that, we have a pendulum suspended by a string. This sphere is called a bob, and this is hold onto a iron nail, or you can hold by your hand also. Only you have to suspend it onto the string. When we take this bob and took it to this position and leave them, then this bob starting doing to and fro motion. This to and fro motion is called oscillations made by the bob in a simple pendulum. In class 11th, the question asked in CBSE that derive the formula for the simple pendulum. For this, it's NCERT question. Consider a simple pendulum having a bob attached to a string that oscillates under the action of force of gravity. Let the time period of oscillations of the simple pendulum depends upon its length, that is L, mass of the bob, that is m, and acceleration due to gravity, that is g. So derive the expression for its time period using the method of dimensions. Let here t is directly proportional to the length, t is directly proportional to the mass, and t is also directly proportional to the theta angle made between the half cycle of the oscillating body here, that is pendulum, and t is also directly proportional to the acceleration due to gravity. Here, if bob makes one oscillation, that is to and fro motion is called oscillation, but here when bob is here and it comes from, let's say, bob hanging here, and when we leave the bob from here, then one cycle, that's it, from here to here, it makes 180 degree, it makes 180 degree of a angle, and when it completes 180 and then it comes here, then it makes 360 degree. So we can also write here 2 pi in place of constant that we are going to use it further. Now let t is directly proportional to length and mass, and theta, that is the angle made in between this string and oscillating body, and it is directly proportional to the gravitation. Combining all physical quantities, we get t is directly proportional to L, m, theta and g. Let this having power x, this having power y, and this having power z, and this having power d. Let we are considering it. So time का dimension formula t in bracket this, and removing constant we use removing this proportionality we use a constant term. Okay, now length L, capital L, having power x, and mass capital M having power y, and theta, theta is dimensionless. That means we don't have any dimension. Now g is equals to acceleration, and we know that acceleration g is equals to a, and a is having unit meter per second square, so we can also write here as length time minus 2 k m0 l1 t raised to power minus 2. Okay, now we can write it as m0 l0 t to the power 1 upon, sorry, upon not k, it's l and its power was d now, so x and it is m, it is l to the power d and t to the power of minus 2d. Okay, so now m become m having power y, and l having power x plus d, and t having power minus 2d. So we are just going to compare our equation, this dimension we are going to compare. Now, so I'm going to write it here. 0 is equals to y, that is y is equals to 0, comma 0 is equals to x plus d, and t having power 1, 1 is equals to minus 2d. So it implies d is equals to minus 1 upon 2. So we can put the value of a d here. So 0 is equals to x plus minus 1 upon 2. When this here come, sign changes, x is equals to 1 by 2. So we have got x 1 by 2, d minus 1 by 2, and y is equals to 0. We can put all these onto what we have get earlier, that is t is equals to k l the power, that goes into l to the power x, and x is 1 by 2, and m having power y, and y is here 0, and theta is z, so we are not going to write it at all, and g having power d, that is minus 1 by 2. So now k m having 0, if any body having power 0, it becomes 1, so l minus 1 by 2, and it is into 1 into g 1 minus 2. So we can also write it as l upon g power 1 by 2, and it is also power 1 by 2. So now we are going further, k into, we can also write it as 1 by 2. Okay, it's clear. Now 1 by 2 can also written as root if any body having r 1 by 2, then it can also be written as under root. So now here I already told you about this uh, constant, that is one oscillation made it covering 180 degree. So we generally write it here 2 pi under root Ly g. It's a formula for the time period. We use capital T, not small t, for the time period in the case of simple pendulum. So, okay, hence derived. Thank you for watching the video. Video.